Hi, everyone in the room, and also for whoever is watching online, welcome to CodamX. So CodamX is a series of weekly talks at Codam, where we invite industry experts to talk about everything that is related to technology. So my name is Qing, and I'm your host today, together with Free. So if you have any questions during the talk, that you can raise your hand and we will give the catch box to you. And when you speak to the catch box, please speak directly to the catch box so everyone can hear you online as well. And for people online, please put in your questions into the comment box so we'll get back to you. Okay, so now Free is going to give an introduction to our speaker today.
Thank you. Hello, everybody. So today we are having a talk by Carlo Piovesan, who is actually has done the Piscine here at Codam, the first Piscine, actually. So some of the students here already know him. So Carlo Piovesan works for a company that compiles compilers, and he's gonna talk to us about compilers and about his daily work. Thank you.
Thank you, Fred. Thank you, Chin. Hi, everyone. So this is Carlo, and I've been here during the first ever Codam Piscine, and that was clearly the best one. And there are a few of you I can recognize. I can imagine you're in a very similar position I was at some point. I did not attend Codam for reasons I will cover in a bit. And I work basically, I basically help build a compiler mainly. And so the only thing I'm sort of knowledgeable about is our compiler. So I'm going to talk about that. Plus a bit of whatever. Any question, you just throw it at me because there are a few slides, so I need to fill time somehow. So we try whether this works. There's a bunch of drawings since my boss hates them and I don't. So yeah, it's fine. This is unclear what it is. So what's the problem, I would say, in general? The very broad problem. So that there's a person, that could be me, you, whoever, that like somehow to solve a problem or to solve, no, we cannot use problem again, but likes to do something with a computer. And the person likes to write in a semi-human readable way, but then the computer, that's the funny guy at the end, understand just a bunch of assembly instruction that would be like something at a very, very basic level, like add these two numbers. But then it's even more specific. It's add the number that are in a, pick just these two spots where the numbers are written and add them and bring to a third spot. And everything is very precise and very fast. Since it's very precise, it's also very fast. But it's not. That's no. Actually, it's possible. So one solution, actually, they had this at some point, is saying, okay, you whoever, not me, but maybe someone who works for me, you just write assembly code, and at some point, this was the only possible way to get things bootstrapped. But then, but still, generally, this could be basically anything like C or whatever. And still needs to be translated to machine instruction. One thing I didn't do computer science, I didn't do computer engineering, I didn't do anything of that. I sort of thought it was that there were fun things to learn about, but I have no formal. I've not been formally trained, let's say, or whatever. So I will say many imprecise things. There will be lots of hand waving, but I think it's fine. The idea is that just convey some basic idea about software engineering, basically, if I manage. So we have these, we have that. What's in the middle? It's basically a compiler, let's say. The thing that should take code written in some kind of code and translate it to machine instructions. So the main, I would say, the compiler guys are funny guys. So they came together. They thought, okay, we need a symbol to sort of express this concept, and they come up with this one. It's actually very, very similar to this one, and it's not much better. My son did it. He was very proud, and I thought I had to insert it in the presentation. But if you go look up for the original symbol, it's owned by Apple or something, and it's basically the same. And I'm not sure what the right are for using it. So I'm going for my dragon. It's So there's basically yes. Sorry, I'm all into myself. The main compiler there is called the clang. It's used also here at Codam because it's invoked I think on Mac when you write GCC something, it invokes clang, and it's a really nice compiler. It does lots of beautiful things. It's modular. It's brilliant. It's millions of lines of code, and they thought, okay, for clang we need a symbol, and it's different, but this one it has wings, but it's the same. So in my term, I would say that if we need to define something, a compiler is a translator that goes from one language to the other language. Now we need to do a step back. So I need to introduce myself. I forgot. So here am I. What languages do I speak? I speak a bit of Italian. Mainly Italian, I would say. Then English, then a bit of Dutch, a bit of French, C++. 10 years ago or something, it seemed something cool, and there were some kind of I went online trying to learn about programming, and there were basically some programming competitions that allowed you to measure yourself against others and be told that you are bad at what you do. And in this subculture, everything was in C++, so because C++ is fast and beautiful and everything, and so I learned C++. Plus, friends of mine at university were doing real computer science stuff. They sort of liked the language. They seemed like guy to emulate, so I follow their steps. It's different than C. It's an improvement, I would say, since there's ++. It's clearly an improvement. It's a bit more messy. It's I think with C you can there are maybe 100 pages or so of specification. With C++ there are uncountable, and they're always adding new stuff, and it will never end. But it's also a very useful language, I would say. There's a lot of code bases that are based on C++, and but then it's just a tool. Then like another tool is, for example, JavaScript. I've been in the last year I started despising this language. But in JavaScript you can write whatever and it makes sense. The computer is okay with you, understand you, or maybe he doesn't understand you, but it doesn't say anything back. May return 42, for example, when you ask him something else. But it's also this presentation actually is in JavaScript, so it allows you to do things like I want this pink red that was completely different on my computer, but in this screen is completely different. But it's okay. on my daily job, we basically, I am going to spoil the thing. We are taking this language and we are working in C++, but then we had to basically translate things either in JavaScript or in WebAssembly. WebAssembly is also it's incomprehensible, and there I had a limited icon set, so I went for Dragon. Also, I like dragons somehow. I like Tolkien, so everyone likes dragons, I thought. Then there are a bunch of other languages. There's I don't know. There's you need a bit of math to be able. You don't need a bit of math, but math can give you a bit of soundness. And I liked math when I was younger, and I was not that good, so I never did anything out of it. But I still. It helps you a lot. On certain problem, you have to speak them, or at least a very small subset of, or be able to speak some kind of dialect of math to be able to. I think to me it's but then you can get into programming from whatever other angle. There are a bunch of other stuff. This is Bash or whatever kind of terminal. This is Python to do some scripting. These I learned in the last 2 weeks. It's been HTML5 or whatever, allows you to make websites and stuff. This, I don't know. This is me using my favorite code editor, and I look like that most of the time. It's Vim, and that there's no other choice, I would say. But yeah. So next slide, we go. Basics about me. The whole talk is about me, probably, and but it's fine. So I'm 34, I think. So we go back a bit. 15 years ago, I was a university student. In a really nice place in Pisa, in Italy. One thing that generally I tend either to do. At least I used to think of myself in this way, but then with time you learn a bit how to act. But either to do brilliantly or fail spectacularly. So university failed. It's it took there's nothing to laugh about. It was quite harsh. It's very hard to be told you don't fit. And but then life. I've been a postman for many years. Beautiful job, recommended to everyone. It's very easy it's very easy on your mind, and generally, you have to talk with people, interact with normal people. It's an okay job. Financially is not that viable, but for a bit I will recommend it. Then we go Codam. At some point, I was doing this postman stuff that actually required going door to door to delivering mainly taxes, and people were always happy. Actually, I do have. I do have something for my boss, and today in the office arrived taxes. So here you are. He's the one paying the bills. So. Yeah, if you want anything, go to him, and he will foot whatever kind of bill. So I tend to not be very. I don't know. Codam Piscine. At some point, I was doing this being postman, and I saw this announcement somewhere online that said we are doing this school. I was living in Amsterdam already. We are opening this school. It's 2 minutes from where I lived. I am a very lucky guy, so it was really around the corner. And we are looking for people. You need to go online, play a game, and being told you are smart enough or not. You're not smart enough. And I thought that seemed really fun, something fun to do. So at I don't know, I was not sure what was the best moment to do it, when it was most my concentration level were high enough. I spent a few weeks thinking, okay, when I should take this test, and then one night I was unable to sleep. At 3 in the night, I thought, okay, then we do the test, and then I will fail as we think. I didn't fail for once, or for actually, there are many things but usually, it went good. I received. Actually, then there was some kind of bureaucratical error. I need to go to the boss, and he said, we love you, just come in. And it was great. He is great, probably. Then, Codam Piscine. So it's a month-long, there's a bunch of craziness going on for 1 month. I hear there's someone almost done with it for the 7th time or something. Good luck with the exam. Good luck with everything. Try to be on time. I think I failed 2 exams out of 4 because one time I was late. One time I think I didn't get past the first one because I didn't remember to include headers. The last one went great. So there's hope for everyone. If you get to the very end of the big exam, good luck, and just thank also that guy that probably chose the question. Is horrible. Then, basically, towards the end of the Piscine, probably you know this feeling. You don't sleep much. You are always here trying to do some stuff to try to get norm error every time, but it's fine. And then a friend from university that's sitting here invited me to have a lunch, asked me how are things going with your programming school, and then he said, okay, but I'm looking for someone, and you cannot refuse my offer, otherwise, whatever. He was very very dark. But then he said, come do compilers with me. And I was in a complex financial situation, and in the end, I think looking it back, I would love. I see whoever is at Codam now. I see everyone really happy. I would love to stay here. Then I also had some bills to pay, and in the end was in my particular situation. I was a bit older than most. I was older than most. There were many things for which my situation were different from the others. So I joined. Actually, this T-shirt is as with everything in life, doesn't work. Or printing T-shirt is very good. It's very bad. So I work for LeaningTech CodamX, but it's unreadable now, as a compiler engineer. So I probably wasted already half an hour on nothing, but I hope I get some love back, so it's fine. So back to the problem. We have some human code like C, and we have some assembly. How we go on bridging this gap? How we go? Some. Any idea? Throw.
Apart from optimizations on compilers that already exist, why would you make a new compiler? What would be the point?
Yes, that's a really good question. My answer, it's usually my answer to defuse the question is it's fun. It's a really fun job. There's a bunch of graphs. There are you can live in this very abstract world in which I don't know. You can go very deep and asking yourself whether 2 is equal to whether a number is actually equal to that other number, or whether you are accessing your you're going very deeply with the programming, and I like it. Why then? What's the point actually? I can skip a few slides, it's fine, and then we go back. Or let's say I will answer in a bit. Let's say any other question? Okay, can I answer you in a bit? There's a slide later. Someone wanted to ask something at some point? Don't be. We go. Okay, so how you build a compiler? Actually, one objection question mark. Then you could say, yeah, you can get it slightly easier, how to build an interpreter, but then interpreter and compilers are different, but an interpreter is somehow... So for example, let's say that you write JavaScript, JavaScript is not compiled, or Python, and it's not compiled, it's actually run as it is, there's no one saying to you, you forgot to initialize some variables or whatever. Because actually there's no, let's say you write something that, yeah. Okay, step back. I don't know anything about this, so I am not, but let's say that, that there are similar problems, that how you build things is similar. Then the question could become how to build anything. There's no much connection between this question, but then this is something I would like to mention here, is that when you have a problem that's complex and big, or even small, it doesn't matter, usually, or one way to tackle it is just to split it apart. You try to say, okay, how you go from this to this. It's very complex to do it, to do a single function. Let's say you want to do a single function that takes in input an array of character and gives back in output an array of assembly instruction. It's doable. Yeah, everything could be done. But even if you choose a very easy language to start with, and you want to do very little things, but then the complexity will catch up. And yeah, so basically, this is something very general. And I find that it's one of the most interesting things about programming, that gives you this way of looking at things. And when you have a problem, you try to look for ways to simplify the problem. So let's say we make some random drawings. So someone said, what you said earlier? Yeah. But you said something more specific that I forgot because I'm very bad. But basically, yeah. In this case, with the compilers, how you go from here to here, generally, or yeah, one way of seeing is that you split the problem into parsing or doing stuff with the input that's written in this horrible human language. One could write in here whatever kind of input, could write, hi mom, I love you, or whatever, and you still need to parse it and give back either some kind of warning or either some kind of errors saying, no, actually a love letter to your mom is not it's not okay here. I was expecting something like a type or a function or something. Or should be able to parse it and transform it to something, to some representation of what was in here, but that's more workable, that you can work with. Then there's everything may seem obvious. If so, that just tell me. Then you do some transformation on it, and then you do this part. Actually, the first part and the last part, especially the first one, they are quite complex. But we will not go into them because I mostly worked on these internal parts, so I try to. So basically, how it is. I started working at this company, and we do a compiler, something very big. Then someone told me, okay, then just forget that this exists. Forget that this exists. We go deeper. You abstract things a bit, and things will be a little simpler. So, one thing I forgot to mention, these three things also, computer guys or girls are funny. So this is called front end, and this is the thing responsible for checking, processing input, and telling it to you that there's an error. Then there's a back end that emit the target-specific code, and then there's a middle end. I don't know why middle end, but it was fun. Probably any question. I'm losing someone. No? It's good? Okay, good. So now back to the same problem. We want to optimize this. How we do it? We split the problem. We say, okay, on one side we build a representation. This is called internal representation in most compiler, I would say, or in the compiler I work in. And then there are passes. But these two concepts are basically, on one side, you have the data structure, so actually how the code is represented, plus what invariants there are. So, for example, one invariance could be, hey, I'm giving you this function, and we are going to start from the main. And you try to remember that we start from the main, don't forget this. Or that we start somewhere, and now it's called main, then maybe called somewhere else in some other way, but try not to forget this. And then there are a bunch of transformations that do a bit of magic, try to optimize things. But then basically how the compiler is structured is that how really the source code is structured is that there are a bunch of there are a bunch of lines about how you represent things, and then a bunch of lines about how you transform things. And this is very abstract, and I don't know what I'm doing. So, very fast. We go very. Okay. What is this internal representation? There's a bunch of things written, but it doesn't matter, actually. The problem is always the same. You have something that's very complex. You have you are compiling a big whatever piece of code, and it could be you work with your team for a month on it. So there's a bunch of files, a bunch of folders. It's very big, and this would be, let's say, at some point. This very big overview, it's called a module, but then that represents some global state, some plus a collection of function. But then the compiler actually split the thing, and also who works on a compiler split the thing in. So basically, this is like a file. Let's say this is a file. There's a bunch of functions. There's some global variable. There are some headers that say, oh, do remember that this function exists somewhere, so please link to them or keep in mind that they exist. Then there are function. Function is basically what a function is in programming. They do not pop one-on-one, so if you write a function, there's no guarantee that the compiler will treat it, will start as a function, but then can modify it, can do whatever it wants. But a function still is some limited. It's a bunch of things that interact with each other, but not with things that are in other functions. So we go. I think it's better if I skip this part. I will go for an example. I think it's easier. Why do we need a? Oh yeah, sorry. This is probably I should have mentioned earlier. Why do we need an optimizer? And the answer is we don't. This was my beautiful drawing I did. And then actually, if this is a valid internal representation, I will go back to the internal representation later. So, but if this is a valid internal representation, and these are a set of transformations that we did here, actually, if this was valid, we can also generate code from this. So say that we had this working, and this working, someone else in the team did it, I don't care, or you found it already ready-made. If you have this component and this component, you don't need the optimizer at all. So we good. We actually solved all the problems we had. We still need to. So this guy, the front end, will take care of generating a valid internal representation. So the internal representation actually we do need. Then this guy, the backend, will take the internal representation and transform it into assembly. But then we don't need the optimizer. So good. We good. Why do we need one? Why do we may want to have to optimize things? Throw.
To make it faster?
Yeah, but why? Yes, but yeah. Say that so what you were saying? There's limited resources. Right? Yeah, say it to the box because so he said that there's limited resources.
There's limited resources.
Yeah, but then there's also limited resources in doing. Yeah, we cannot stay the whole day doing optimization. We can go on forever on optimizing things, and there are also limited resources. Plus, actually, while the compiler compiles, it's my time. While the code executes is probably someone else's time. So probably we are good without optimizing. Probably, I don't know. Or maybe it's the other way around. So if we do some kind of, even if we do it for ourselves or we do for someone else, yes, the idea is it's probably worth spending some of the limited resources now and to have it faster in the multiple iteration. The basic idea is that if you compile things once and execute them many times, could be nice to have them optimized. This is not always true, actually. That there are a bunch of cases where there's, for example, let's say that there are a bunch of cases in which the optimizer actually happen when. So let's say that okay, we will show later a case, but then say that you compile it once and execute it just once. Then the compilation time is a scarce resource. But normally the scarce resource is your user battery power or the time of someone playing a game that doesn't want it to go faster or whatever. So yeah, generally we need an optimizer. Then there are still more beautiful drawings of mine. I will show you some transformation passes that are basically it's a way also to concretize what the internal representation were. So beautiful drawing of mine or writing of mine. So let's say that we have this pseudocode. We have some function, call it malloc. Common sense, I like it, but it's that returns something. Let's say address somewhere. So why am I doing this? I will show you. I will give you more. I will show you some small optimization, some medium optimization, some bigger optimization. But I actually. So I will skip this actually. The idea is the idea here. What you can. Okay, you can realize, for example, this is. A plus 12, you move the address, you take some other address, or you do the other one plus 36. But then this is, you say, oh, actually, if I want to be as slightly smarter, but I didn't do it in the other because I was in a hurry to prepare the presentation, you can say this is a plus 48. And where does this lead us? Nowhere. But then, let's say that we can, for example, find that B is never used anywhere else. So we can write here C equal A plus 48. That's still slightly better. But then, for example, we notice that B is never used anymore, and we take it out. And you may think, okay, but what does this to do with programming? The idea is that, or with you, or whatever. Okay, the idea is that these transformation passes that the optimizer do are very limited, or some are very limited. You do small modification, but when you basically start here with no, I will go for. So this is an example. Sorry, I should have. I'm a bit underslept. It's fine. So the idea is that optimization are something are relatively small thing or simple thing, or even better, are things that look at with a very narrow scope. Here we are only concentrating on these three things, or what is a bit behind. But then we just notice there's a pattern, or there's something that could be done better. You take this out. Good. We go for something slightly more complex. Say we want to compute, we have some kind of loop. This is basically a for loop. It's you take a number in input, and you start with a equals 0. Let's say that a start with 0, and you go. This is how a program actually works, or it's represented. It's a equals 0, then it goes in here. It does +1. Let's say that this program then compute the square root of n, calling an external function that's somewhere else. Then it asks, is a still less than the square root? We go back, and then we go back, and then we go back. At some point, let's say n was 50, square root is 7 something. This will become 7, it starts at 0, then it's 8. And then it says, oh no, now we go and we go to the further step. But let's say that we also have some information about this small function here, that this function do not touch in any possible way the external state. What we can do slightly better if we were to write. So this is basically for a equals 0, while a minor than the square root, a plus 1. A equal a plus 1. So this is something slightly cooler. Let's say that anyone has any idea what could be done slightly better? Apart from there's one obvious thing, is that we know how. Any idea? Do we want to do it in the? I will repeat. You also do first the square root. Where do you want to do the square root? So here. Outside. Oh. Can we do that? Yes. Why not? The idea is. We are calling this external function. This is where function. This concept of function is useful because if you say. Okay, the other function will do something but will not modify my internal state, you can say, okay, I will move it here. If this does not modify the internal state, the internal state in any way, plus it doesn't modify the external state because this function somehow has some label that says I'm a cool function, I will not touch anything that's around. So there's no counters, there's no anything inside here that will be modified. There's no global state that will be kept by this function. We can move to this. We can move the square root up here. Then we may have another transformation that realize that this actually, it's probably, you can actually set the value a directly to the right value or whatever. Also a, you can, since you are doing this +1, +1, +1, +1, +1, you can probably move it out, probably, depending on a bit of condition, external condition. But what's the difference between this and this? Anyone has any idea how costly is computing, I don't know, square root? Yeah, that could be I have no idea. I just this question just came to my mind and I didn't check beforehand. But I would say it's more or less okay. But actually, whatever it was, even let's say this. So this cost 40. This plus 1 costs 1. The comparison costs another 1. Let's say it's all very hand waving, and so this now costs 2 per iteration, while here it costed 42. 42 also nice number. Then, so every time you do this cycle, let's say this, you have gone from 42 to 2. Let's say it's, probably I should ask someone that knows something to quantify the number, but it doesn't matter. Plus we changed the structure of the program a bit, and this may allow us to do more transformation. For example, we can realize that these can be moved out somehow, so we don't need a loop at all. And
instructions, it's about reducing those number of instructions.
This is a good question. So what are we optimizing for? Any idea? One idea would be reduce the number of instruction. Yes? Runtime. That's runtime. It's actually the main concern for. It's probably tied with the number of instructions. That's you use if you have less instruction, you have less thing to do basically. But then it's runtime. You would also say that probably things that are inside a loop are more costlier than things that are outside a loop, because a loop will be executed. You don't know, but you can estimate that it will be executing. Yeah, this is for sure. For sure, this is executed more. Yeah, this is executed once. For every execution of this, there will be at least one execution of this. So at least it's the same, probably way better to move it outside. So one thing is execution time. What could something else be? The size of our program. Yes, yes, because for example, you need to send your program over the net, over the web, and you may want to, or maybe you want to distribute in a floppy disk. There's no floppy disk, but whatever. There are some, there could be either some strong, some limitation on the size, for example, or you as small as possible is better. Anyone want to do? Yes, how much memory it does. There's a trade-off generally. So if you use more memory, you may go a bit faster. But generally, or there are cases in which you can say, okay, then would I go faster if I can use more memory? The answer may be yes, but then there are cases in which memory is limited. So, or you have to do with whatever memory you have, so you make it do.
Side effects as well. I mean, if square root itself causes some side effects, then with every loop, you're causing those side effects to.
Okay, in this specific case, to do this transformation, we should be should be sure there's no other side effect. But but then every time you call for example, one thing that you could maybe it's not your execution, the thing that matter, but how much resourcing or I don't know, maybe the slow thing is the input output or whatever. There are. So the idea is that you sit beforehand and you try to say, maybe it's not you, maybe it's your boss or the head of school or whatever, try to say, okay, we actually want to optimize. Optimizing means this direction. We want to go in this direction. And then you try to go in that direction. It's generally, there are a bunch of transformation. So this is actually always better. So the number of instructions remain the same. Possibly could go away if you manage to erase the loop. But this is always better. There are a bunch of optimization that you can do based on your specific needs. But there are a bunch of them that are very generic, yes. But yes, so this is also that you need to have some direction. Yeah. This is, yeah. Any question, anything?
Compiler actually do that optimization right there? Like if you actually had something like that was a square root within a loop, would it actually figure that, well, I can actually just not do this every loop and pull it out in the compiled code that it would compile?
Depends what you instruct your compiler to do. You can, I would say that if you, even at the basic optimization level, I would say this seems, Alessandro, this will be done in any cases?
This actually depends. So
okay.
In reality, the reality of this is that...
No, we go shorter.
The reality of this is that this actually depends on the F, no matter, no flag of the compiler.
Ah!
As pure T on the C, by the F, no Y.
No, okay. Doesn't matter. So sometime. The answer is sometime. So, but if you instruct the compiler with the right compiler flags, like plus how your library for S, how the library, who've written S square root, what did he do? Because if somewhere he said, I want to allocate some memory and write something, a song I like, and then do a bunch of other stuff, this is not true anymore. But let's say you have a normal or a decent implementation. Most compiler, if you pass O2 or something, will do it, I would say. Plus something else. But generally, if you want your compiler to do it, any compiler will recognize this pattern and this problem, I would say. But then, a very cool presentation would have this done live. But actually, we have a limited amount of time. And you have all the time that you want this evening or whenever you want. You write a small program and you measure. Or you try, you think of a method to measure, or to check whether this is optimized away or not. There are better ways than others, but you can figure it out. We can do it later if you like, and we can check whether at what point it happens or not. So, but this is something that a compiler is possibly able to see. Yes. Any other question? Yeah.
In what do you write this compiler?
The compiler is actually written in C++. I just saw it. Yeah, the compiler is written in C++. One curious thing is that then the compiler is fed into the compiler. Because the compiler is just a regular program written in C++, a human language, sort of a language writable by humans, and it's fed back into the compiler itself, or a different version of the same compiler, and to see the output. I just noticed 11 minutes out. I completely throw away a lot of time. Yeah, then we go. This doesn't matter. The idea was, let's say you have something like this. You have a function main that calls function A, that calls function B. Then we have function C that calls function A, function D that calls function B. What can you do here? We go very fast. Anyone has an idea? Yes, we can remove these two because they are actually not used. But maybe, yeah, this seems obvious, but maybe you had some this is, for example, debug code or whatever. And you at some point had written here, whenever I'm in a case of need, call function B, and function B will print the state of the function or whatever. And it's very useful to have function C and function D. But then, if at some point you ask the optimizer to work for real, he will recognize that C and D actually do not have any sense. This is called global dead code elimination. It's very cool. I also did a very, very small modification of this. I'm very proud of that, but there's no time. So question that you made before. What do we do and why we do it? So this was the last step. So you have assembly code. Actually, compilers are really nice. One complex thing is that you had, in the easy way, you just target one architecture. But generally, you may want to have your programs built for macOS or for whatever. So you have multiple different architecture for 32, 64 bits or for a cell phone or for whatever. So actually, the last it doesn't matter, I cannot go back, but there are a bunch of final steps that target different kind of funny guys here. What the company does, the idea behind the company is that this is very nice, but then there are certain use cases in which targeting a very specific architecture can be limiting. So you may want to target, what's that? Also a browser, drawing of mine, it's a browser. It's very friendly, it helps you out, and it runs on any cell phone or on any tablet, on any kind of computer, possibly even, it doesn't need, The idea is that this will stop being x86, whatever, but I had a limited amount of drawing time, because I had some work to do. And the idea is that the idea behind the company, very generally, is that if you target a browser, there are a few advantages. But this actually is not my job, it's the sales team job. Do you have an idea what kind of advantages there will be on targeting a browser? So what we do is we take a program. Let's say I tried this morning with his program with Castle of Wolfenstein project to translate it to go on a browser. I didn't manage in time. We'll do at some other point. But what are the advantages of taking a regular program, or I don't know, you want to print a fractal, you want to compute whatever thing you want to compute, or you have a game or whatever. What could be the advantages of giving a browser as a target? So of obtaining something that can run in a browser. So anyone that has a browser can run it. That's good. There's a lower barrier of entrance, and it's more universal or whatever. It's way easier to get your thing out there. Yeah, you target one. Yeah, hopefully you target just one instruction set. Then there's a bunch of different browsers. There are a bunch of different versions. So there will still be some problem to be solved. But the idea is that since we target just a subset of what most browsers do, then yeah, you just have one target. That can reduce whatever cost for whatever. Anyone that wants to join our sales team? Any idea? Could be, for example, that this guy here was made in, was made in the 60s, and they are not building it anymore. This is the very specific processor you were targeting. And let's say that you lost whatever source code, or you don't have the tooling anymore to do the translation in this direction, it may be cool to still have a way, this is not XST, whatever it is, to run it. This could be cool, I don't know, for some guys, for some particular use cases. But yeah, this is what we do in practice. I had another few slides, what's important and what's not. Yeah, okay, the advertisement part is, no, I think it's not the advertisement. Yeah, this is the main idea. And how you do it, building a compiler that allows you to do it automatically. This is the general idea. Then specifics, who cares? Day in the office, I have many small things to share about how it's working for real. It's really nice. There's a lot of tractor. I like programming a lot. There's a very fast feedback cycle. So I don't know, you try something, you run the test failed. Then you run it, then you modify it, you run the test failed. Then you modify it, the test passes. Then you say to your colleague, you say, oh, I have it working. And he has another bunch of tests that he keeps secret, and you fail at the first one. And you have been, yeah, but it's okay. It's also really nice. This is something also I wanted to mention before we run out of time, that I entered from a very junior position, but that's actually beautiful. This is also true for most of you. I would say that there will be more or less experience, or you'll be different. Everyone is a different person with different skill set. But being the younger, or being not the younger, I'm not the younger, I'm actually the oldest. But being the dumbest is incredibly powerful. Yeah, first, you can always play dumb, so that you're never at fault. That's actually very useful. But the idea is that you will get things wrong 90% of the time, but it doesn't matter. The idea is that you are trying to learn something. So the idea is that maybe in 6 months or in 6 years or at some point, you will get it right consistently. Plus, when the time you get it right, it's actually all on you. You can feel good and whatever. But then actually, plus, you can and should rely on others, because if you enter at the bottom of the food chain is a horrible expression. It's also, since we are running out of time, and I can imagine someone will come and interrupt me anytime. But the very nice thing is that you have a lot of things to learn, and this is really cool. And you are always allowed to ask questions. While my boss can very rarely ask questions, because I would feel then I'm entitled to take a shot at him. He actually should act as always as all the questions, all the answers. But being young, or whatever this means, usually with your job title there's written young before it. It means that also it's also good for the team, for optimizing the team output or whatever, that you should learn. You should keep learning, and at some point you will become a better software engineering, and will help someone else out. In your way, you will also help your colleagues with many other means, by doing some simpler task or whatever, plus providing some fresh ideas. You are entitled to try new things and to fail badly, but because that's just fine. You're also entitled to say, I want to put drawing things, and someone can say, actually drawings do not work. We tried and they do not work. But yeah, you try and then you fail. It's fine. The point is not failure or success. Also, this is another thing I wanted to mention. It's that you will get it right at some point. It's fine. Quiz time. We have another minute, hopefully. Yes? No? 1 minute. Okay. We have a function that's written in C. So the question is, what's the output? We are given you can think about it. Sorry, I cannot. You can think about it for 1 second, and which one will be? Which one will be? Yeah, who says 0, 0? The thing printed. Yeah. Anyone want to take to try? 0, 1 is it's 1. Anyone says 1, 1? Yes. Yes, we have everyone wins because it's going to be random stuff. So I would because we forgot to initialize things. And the optimizer here can recognize that we don't have a clue, or we are telling the compiler, we don't want to know what's in A and what's in B, so do whatever you like. You can print anything. That's cool. Got it? Or not? Did you tell me? Should I go forward? Yes, sorry.
Okay, thank you. Is it on? Yes. Thank you very much, Carlo, for the talk today. We can now continue with the Q&A. So, well, let us know if you have any questions. I have a question. How much did you know about compilers before you?
Nothing.
Nothing.
Or very, very little. I knew about. They thought the way I see it now, having worked for a year and something, is that they thought, okay, he may understand these things, and we are going to teach him, and this is good. Yes. And but then the idea is that you start from a very I didn't know any of these. I would not be able to say most things just a couple of months ago. But you begin from something very small. You have been tasked with, can you recognize whether the small thing about the numbers? And you think, okay, arithmetics, I can do that. And then you go graphs, you go more complex things. But this is also very general. That's, yeah.
Question in the back. Thank you.
I don't know if I answered, but the idea is that you, with many complex with complex stuff, you start from a small thing, and then you go, you build on that on your foundation, and sometimes you can also you think you understood things, and but then you fail. Yeah, but it's fine.
So Carlo, of course you did the Piscine. We're focused on C, and in my experience, it seems like by learning C, I start to understand things about other languages that maybe developers in those languages don't quite understand. Yeah. I'm wondering, through working with compilers, do you feel like you have a deeper understanding of languages in general?
Okay, can you pass the? I will think so, but then you also have a more limited field of view. But yes, I think it's very that there's. In general, what I can say that bridge, it's all compiler. It's a bit like C. It's very low level. You go with very fundamental concepts. For example, is square root function square root? Does it touch anything in the global state? Could well be that. Actually, thinking of you could well think of use cases in which you modify the global state, whatever. But then when you go about writing something, you think, okay, but then what will happen of this? I am provide. The actual thing is I am providing So the thing I learned is basically compilers can do a bunch of magical stuff, but it's actually not magical. It works with the information you're given. So if at some point you are writing, the way it works if you are writing some code is not that you are, or at least if you're writing C or C++ or some program, there's some things that will be compiled that will be compiled, is that actually you want to try to keep as more information as most information as possible in the code, so the compiler can then do his work. Because if you are saying, okay, I'm taking a pointer, then I'm dereferencing it, I'm doing whatever. Yeah, I don't know. Yeah, there are cases in which I don't know if in square root you would just say printf some things. Then you are telling the compiler you actually want things to be printed. So yeah, I cannot optimize these things out, even if I recognize that maybe I do have a better solution. But yeah. I'm not sure if I said anything of value. Questions? Any question?
Yeah, another question.
Here's the box.
With the catch box.
I was just going to say I like the drawings.
Yeah, thank you. I also like them. Any?
Hey, Carlo. Thank you very much for this. That's really a neat topic here, compilers. My question is, so I understand that at some point you kind of cut the pipeline of transformation to switch from assembly generation to JavaScript or WebAssembly.
Yes.
Something like that. I was wondering, how deep into the transformation do you actually stop and plug your own process there? Is it close to the assembly code or rather soon in the transformation pipeline?
There's the main technology I'm working on. It's very cool. It's an open source compiler. It's basically a fork of clang. You take the source code, so you have all the informations. Then, normally you would go like this. You call, I did an example for C++, but then the idea is that you call wherever it's installed. This is where it's installed on my computer, our compiler, but then this is actually clang with some added features. You pass it the source file, then obviously there will be multiple source file, but whatever. And then it gives in output, let's say it's a JavaScript program. And then, with this is very cool because you actually have all the informations. There are a bunch of quite complex stuff. Because, for example, normally I'm going just a small bit that I still have to understand, but on our compiler, that basically normally when you target assembly, you have assembly is basically a soup of there's a memory block. It's just memory with random values in it, and so you can jump from one place to the other. You can do pointer arithmetics. You can do multiple stuff. With JavaScript, you cannot. You cannot compare two pointers, and so there's a bunch of difficulties because I will show you later if you like. I have my computer with me, but higher level. So one thing is we start with source code, we transform into LVM internal representation, and from there we do our own. We do the standard optimization plus our own to get it in a state where it can be converted into JavaScript by the final step. We have a custom final step, but that's relatively, I don't know, relatively speaking, it's, okay to understand. It's just, so that's one thing. On the other end of the spectrum, there's this other thing that it's not, we are not actually working on it, we are working on it. Especially, the more, I'm not working on it. I'm concentrated on these that allows these to go slightly better. So we take these. This is also, I think it's a nice concept about computer science. That say normally there's some assembly that talks to the operating system that talks to the computer. I'm not sure whether this makes any sense. Then you want to target a browser, so you put something in between. Let's say it's me, that to the assembly talks to him. The assembly asks for some memory, and I give him back some memory.
That is translated directly into JavaScript. It's not a representation that is closer to C++. Because the follow-up question with that was that if you have
so basically there are two ways, there are two ends of the spectrum. Either you start with this, and you interpret it, and you do a virtual machine on the assembly, or you take the source code, you have way more information, and then you transform the internal representation into JavaScript. What was the second question?
The follow-up question was, well, I'm trying to understand if the JavaScript code that is generated is actually close to the assembly or close to the C++ that was there before.
It's very close to the...
So it's really a set of instructions, a list of really short instructions similar to the load, move, and so on.
It's the problem is that when you generate some, it's very similar. I would say it's very similar to the internal representation, to the end step of the internal representation.
Yes.
So there's the control flow. There's a bunch of function. Each function has its own control flow graph. There's a bunch of, but then it's the internal. The thing that's most similar is the internal representation of LVM. If you know, if you don't know, go check it out. It's beautiful, or it's done well. It's also very fundamental. There are also, yeah, you can look it up. I should have written. There's some. Normally, you use just C-lang without the plus if you do C. But there are a bunch of other tools that are really cool if you want to understand things on a deeper level. So whenever things are not working, that there are tools to disassembly, actually to let you see what the compiler is seeing. So yeah, that's cool, but yeah, it would be needs way more space than that. I did that on, this is me. At some point we were hiring, I'm not sure if we are hiring anymore, maybe we found someone, but we are also looking for, this is me. This is the projector. I should say to Mick that the pink is really not working.
All right.
And I don't know, for any inquiries, bother me later.
Okay. So I think we will wrap up now. And then if anybody has more questions, Carlo will be around for...
Yes.
Yes? Okay, great. So please, everybody, one more applause for Carlo.